Let's turn our attention to bond valuation, how we're going to value a bond. Now, a bond provides, of course, a bond is a debt instrument that a corporation issues, but a bond provides if we think of it in terms of cash flows, it provides an annuity stream of interest payments. So every period, the corporation will make an interest payment on the bond, and then at the end of the life of the bond, the corporation not only repays any interest that's due at that point, but it also makes a payment of the principal amount, and that occurs at the maturity date. Now, if we want to value a bond, we have to identify the cash flows, which we just did, basically the interest payments and the principal payment, and then we have to have a discount rate. And the discount rate that we use for bonds is determined by the market, but we have a special name for this discount rate. The discount rate we're going to use is referred to as the yield to maturity. So in Chapter 9, we used a little symbol I to indicate the interest rate at which we were discounting cash flows. For this bond, we're going to replace that I with this symbol, this capital Y, which just refers to the yield to maturity. There's no real difference. We're just changing the notation. We're not changing the meaning here. What we previously thought of as I is now this capital Y, the yield to maturity. And the yield to maturity is a rate that's determined by the market. The market looks at the riskiness of the bond and will apply a market interest rate, which is this yield to maturity, to the pricing. So as we move forward, the pricing that we're going to the price we're going to find for bonds is equal to the present value of all of the interest payments that's received on the bond, plus the present value of the principal amount. And the discount rate we're going to use in all these instances is the yield to maturity. Before we look any farther, let's look at a graph, or not a graph, but a picture of what the bond payments are going to look like, just so we have a little better understanding before we move forward. What we have drawn up here on the is a timeline of interest payments and principal payments received on a level coupon bond, which is the sort of bond we're typically going to be dealing with. Notice that the payments of the coupon amounts are occurring every period, and they occur every period throughout the life of the bond, including a payment that's received at time T, which is the maturity date on the bond in this example. So we have multiple interest payments that we're receiving, these coupon amounts, and we are also going to receive at the end the face amount, which I'll just circle in blue, or the principal amount. We could refer to this as the face, the principal, the par value of the bond. All those things mean the same. When we're valuing this, when we're finding a price on the bond, we're finding the present value of all of these. So the present value of all the coupon payments is just this term right here. And that may look very ugly, but we need to recognize what we really have is an annuity. This is an annuity, and for the annuity, we're really just going to value this as C, this guy right here, times the present value interest factor for an annuity, which we can find in Appendix D. So we've already worked through that. So all of this other stuff that we have, other than C, is just the formula that's all embedded in the present value interest factor for an annuity. You'll find that in the footnote, in one of the footnotes in Chapter 9. So we really can just go to the table to deal with that. The other part, our face amount here, we're going to find the present value of that. And so that's what's going on in the denominator here. We're just finding the discounted value of that face amount. So that's essentially the process for valuing a bond, is just using present value. Let's look at an example of a bond. Let's find the present value, and what we're referring to as of January 1st, 2010, of a 6 3/8% coupon Treasury bond with semi-annual payments and a maturity date of December 2015 if the yield to maturity, meaning the discount rate, is 5%. Well, drawing the timeline first, this is a 6 3/8% coupon Treasury bond, but it's got semi-annual payments, so really that's a little over 3%, 3.1875% every 6 months. So notice that our timeline has, each segment is not a year, but is a 6-month period. So this is after 6 months, this is after a year, and there are payments that are being received every 6 months of $31.87. We get all of those payments out to the very last payment, which would include that $31.87. Okay. In addition, at the end of 2015, we're going to get the principal amount back. This is a $1,000 bond, so that's the $1,000 right there. So we notice that at the very last payment we get not only the principal but also some interest. When we value this, the value of our bond, the first piece of this, that's the present value interest factor for an annuity, and that's the $31 annuity that we had above. Let me clean up this a little bit. So that's valuing all of the coupon payments, and then in addition, that $1,000, we're finding the present value of that, and because we had semi-annual payments, we're going to divide this 5% that we had above. That 5% is now 2.5% to deal with the fact that we had semi-annual payments. So this is just an example of a bond, and we'll now jump back into sort of the formula that's going to be used in a more general form. Okay, let's look here at the top in blue. We have, this is taken straight out of the textbook, the price of a bond, and this is just the formula that we would use for the price of a bond. The price of the bond is equal to the present value of all of the interest payments plus the present value of the principal payment that's received at the end. So the first, I'll circle it, this is an interest payment that's received at time t. It's discounted for t periods. And the discount rate that's going to be used is the yield to maturity. Okay, we're going to do that for each individual payment. So the t just indicates a particular payment, a particular number of years out. We do that for every interest payment, and then we add up all of those present values. That little notation on the left, a summation sign, we're going to add up every present value that we've calculated from 1 up to n. Okay, and we'll do this entire process on the left, this entire process, typically using the present value of an annuity formula or one of the present value interest factor annuity the present value interest factor annuity table in Appendix D. So that's one piece of it. That's valuing the entire stream of interest payments. And then, of course, the second piece is we're going to add to that the present value of the principal amount, which is designated as PN, the payment we're going to receive at time N for the principal amount. We add all of that together, and we get the price of the bond today. Notice, let me clean up a little. Notice that at maturity, the price of the bond is going to be PN. That's what we're going to be paid. The principal amount is what we're going to receive at time N, so the bond's got to be worth exactly what we're going to get for it at that last moment in time. The price of the bond today is the discounted value of that plus the discounted value of all the interest payments. So the various terms included in that item above, in the equation above, are defined here. PB is the price of the bond. I sub t are the interest payments. P sub n is the principal amount at maturity. T is the number corresponding to the period in which the interest payment is received, or the principal payment, and T runs from 1 up to N. N is the total number of payments and the maturity date, and Y is the yield to maturity on the bond. We make some assumptions here. Let me again clean up a tad. We make some assumptions here. Let's assume that our interest payments are $100 on a principal amount of $1,000. So notice that our bond is, the coupon amount is 10% of the face amount. We're also going to discount this at a yield to maturity of 10%, but that's just coincidental. Okay, the fact that the market is requiring 10% and our bond is paying a coupon of 10%, that won't always be the case. It's a coincidence in this instance. So we're going to assume the total number of periods, there's 20 periods, and the price of the bond is what we need to find. So we substitute in these values. The interest amount is 100. The discount rate, the yield to maturity, is 10%. T runs from 1 to N, and in this case actually N is 20. Okay, we've actually substituted in for N, and that 20 also occurs out here at the very end. So T runs from 1 to 20 because N is 20, and the face amount was 1,000. We could go through and add these up individually, or we can appeal to using the method that we've devised in Chapter 9, and let's do that next. So the first thing we're going to do here is we're going to find the present value of the annuity portion, the interest payments, which are $100 payments for 20 years at a discount rate of 10%. We'll use the same method that we used in Chapter 9. The present value of an annuity is equal to the annuity amount times this present value interest factor. In this case, N is equal to 20 periods. I, our yield to maturity, this I is the same thing as Y. Okay, I is equal to 10%. We go to table or Appendix D. We find a value of 8.514 in Appendix D. The present value of all of those interest payments is $851.40. In addition to the present value of the interest payments, we have to find the present value of the principal amount that's going to be repaid at maturity. That we do here. The principal amount or the par amount or the face value of the bond is paid at maturity. We're going to find the present value right here, the $1,000 future value times the present value interest factor, which would come from Table B, where N is equal to 2, or I is equal to 10%, remembering again that this I is the same thing as Y, the yield to maturity. We substitute that in. The present value of the principal amount is $149. So what's the present value of the bond? Well, the present value of the bond is found down here, where we just add together the present value of the interest payments and the present value of the principal amount. We come to the total present value of the bond, or the present value of the bond is also we call the price of the bond. That's how the market comes to a price, is it applies a discount rate to all of those individual payments. Now, in this instance, you'll notice that the price is $1,000 basically. It's the same price as the face. It's the same value as the face value. Now that's not always the case. The reason it works out to the same value is because we talked about the coincidence that we had earlier that, let me clean up to just sort of make this point. All right. We talked about the fact earlier that the yield to maturity on this was 10%, and that also happens to be the same as the coupon rate percentage. This bond is paying $100 on a face value of $1,000, so the yield to maturity in this case, what the market requires is 10%. What this bond pays is exactly 10% of the face amount, and therefore the market prices this bond at the same amount as the contract price of the bond, or $1,000. If the market required anything other than, in other words, if the yield to maturity were anything other than 10%, this bond will not be priced at $1,000.